So we have another problem. The problem says that a man is sitting on the shore of a river. He is he is in line of a 1 meter long boat and is 5.5 meter away from the center of the boat. Let's draw a diagram for this. This is the river bank. Say this is the river bank, and say this is the river. Okay. Let us consider the man is here, and there is a boat here. It says the boat is 1 meter long. Also, it says that center of the boat is 5.5 meter away. So obviously, near end of the boat is 5 meter away, and far end of the boat is 6 meter away. The question is, he wishes to throw an apple into the boat. Fine. And he can throw the apple at 10 meters a second. Find the minimum and maximum angles that he should use. Now, at a certain angle when he throws the apple falls here. That means it's the near edge of the boat. Let us say this angle is θ1. And he can use another angle so that apple goes a little far away and it goes to the further end of the boat. And let us say this angle is θ2. Let us find out these two angles first. To find out these two angles, we use the very known formula which says the range of a projectile R is equal to U square sine 2 theta by G. So for the near end of the boat, when the range is 5 meter, the equation becomes 5 equal to U is 10 meter per second, 10 square multiplied by sine 2 theta by G. Here, for the convenience, let us consider G equal to 10 meter per second square. Let's take G is 10. So this is equal to 10 sine 2 theta, which makes sine 2 theta is equal to 0.5 is equal to sine 30 degree. Therefore, theta equal to 15 degree. So this angle is 15 degree. And if it throws the ball a little further away to the further end of the boat, which is 6 meter away, then using the same formula, 6 equal to 10 square into sine 2 theta by 10. If you calculate the same calculation, you will find theta is equal to 18.5 degree. That means the boy can throw apple any angle between 18.5 and 15 degree, and the apple will fall somewhere on the board. Now there is a next tricky part of this question. See, in any projectile, there, if it is projected at an angle theta and it reaches the range r, then there is another angle of projection which is 90 minus theta. This angle is 90 minus theta, in which case also range becomes same. How? Look at this equation properly. This equation range is proportional to sine 2 theta. Sine 2 theta is 2 sine theta cos theta. Now we know, so long as theta is less than 90 degree, then sine theta is equal to cos of 90 minus theta, and cos theta equal to sine of 90 minus theta. Like cos 30 equal to sine 60 and sine 30 equal to cos 60. That is why the range remains same when the angle of projection is theta or 90 minus theta. And for 15 degree, what is 90 minus theta? Is 90 minus 15 degree is equal to 75 degree. That means this is 75 degree. And for this one, for this case also, it is 90 minus 18.5 degree is equal to 71.5 degree. That means this is 75 degree line, projectile. The ball falls on the, and this is 71.5 degree line, projectile, when also the ball falls on the. That means any angle, that means any angle between these two, also the ball falls on the board. So if we really want to find out what is the minimum angle is 15 degree, and maximum angle is 75 degree. But in between this range of angles, if the ball is thrown in this range of angles, then the apple will be either beyond the boat, either it will go out further than the boat, or it will fall before the boat. That means there is a prohibited angle range of 18.5 degree, and this other angle is 71.5 degree. So this is equal to 0.0. There is a 53 and angle 53 degree range of angle in which is not permitted. So this is the solution. Now let's go to the other problem. This is a small problem, but I thought I'll show you how to do it. It says, two friends A and B are standing at a distance x apart in an open field, and air is and wind is blowing from A to B, right? So let's draw the diagram once again, as usual. Say this is a open field, and this is where A stands, and this is where B stands, and they are x distance apart. And wind is blowing, and it says find the wind velocity it wants to find out. Let us say wind velocity is u, wind is blowing. Now, what is happening? What is the experiment? A beats a drum and B hears the sound time after he sees the event. So A beats the drum. Let us say A is beating a drum and producing a sound, and this sound travels to B, and B is listening to it, and B is listening to it. Let us say this time is T1. And let us consider sound velocity in absence of any air, absolute velocity of sound. It says they want to find out is V. In this case, since air is flowing in the direction of the sound, so total velocity of the sound will be U plus V, right? And the time taken is T1 to reach a distance x. So we can easily write V plus U into time. Let us say this time T1, as we say, is equal to time T1 is equal to x. Fine? Then when A and B interchange their position, then say B comes here, then sound is produced here, and the sound travels and reaches the somebody's ear here. The time taken is T2. Here, the velocity, the apparent velocity of the sound will be V minus U. So the second equation is V minus U. T2 is equal to X. So from here we find 1 plus U1 equal to X. And from here we find VT2 minus UT2 is equal to, say this is equation 1 and this is equation. If we multiply equation 1 by T2, then what we find? VT1 T2 plus UT1 T2 is equal to X T2. Multiply equation 2 by T1, we get VT1 T2 minus T2 equal to X T1. Let us consider this equation 3 and this is equation 4. Then if we just sum up equation 3 and equation 4, find 2VT1 T2 is equal to X into T1 plus T2. From here we find V is equal X by 2 multiplied by T1 plus T2 divided by T1, T2, or V is equal to X by 2, 1 upon T1 plus 1 upon T2. Similarly, if we perform equation 4 is subtracted from equation 3, we find 2u x T2 minus T1. Therefore, u is equal to x by 2 multiplied by minus T1 divided by T1 T2, which is equal to x by 2 and 1 upon T1 minus 1 upon. These are the velocity of sound, and this is the velocity of the air. So here we complete the kinematics chapter. There are some remaining problems which I think they're not very difficult, you can do. But of course, if any candidate or if any student finds some difficulty somewhere, you can always write to me in the comment section of the channel. I shall definitely help you. Okay?